Why are pools 1/3 deeper than they appear? Why can a straw in a glass of water look like two separate pieces? And how can a tractor explain this? Here I have a glass block surrounded by air. A ray of light striking the block at an angle will not pass through in a straight line. Instead, it will change direction when it enters and then exits the block. Why does light change direction at the boundary between two mediums like this? Light travels at different speeds in glass and air. Glass is denser than air, and so light travels slower in glass than in air. We draw an imaginary line called a normal line perpendicular at 90 degrees, a right angle, to the surface where the ray strikes. The angle between the normal line and the incoming or incident ray is called the angle of incidence. The angle between the normal line and the outgoing or refracted ray is called the angle of refraction. These angles could be measured with a protractor. A ray of light entering a denser, slower medium bends towards the normal. The angle of refraction is less than the angle of incidence. A ray of light entering a less dense, faster medium bends away from the normal. The angle of refraction is greater than the angle of incidence. But why does light change direction when its speed changes? Max Planck in his tractor will move slower in sand than on tarmac. As the tractor moves from tarmac into sand, this wheel hits the sand first and slows down before the other, turning the tractor towards the normal. As the tractor moves from sand back to tarmac, this wheel hits the tarmac first and speeds up before the other, turning the tractor away from the normal. To calculate the exact angle of refraction, we use Snell's law, the law of refraction, and the refractive indices of the two mediums. A higher refractive index means a higher optical density and a lower speed. When a ray moves from a more optically dense to a less optically dense medium, some light is also reflected. If the angle of incidence is greater than the critical angle, total internal reflection will occur. If you like this video, leave a comment and don't forget to subscribe to Bricking Physics.